In the last video we were discussing about the numerical method to solve equations. Specifically we talk about the bisection method. So in the upcoming video we are going to talk about the Newton method and numerical method. But this one, Newton's method, another numerical method to solve the equations. But it's required to use the derivative. Okay, therefore it's better to introduce SymPy at this point. SymPy enables you to do symbolic calculations, so you can calculate the limits and derivatives of functions using SymPy. Okay, so we'll introduce the SymPy library in this video. Here it's better to introduce another IDE, Google Colab. Okay, so it has this notebook form. It's pretty useful when you are using with SymPy. So here I will introduce you the Google Colab. Okay, but in the exam you will be using the Spider environment, but here in this video I will introduce you to Google Colab. Try it out first. Okay, then we'll switch back to Spider IDE. Okay, so to go to Colab, you can search Colab in Google and go to this welcome to Colab tutorial link, but you might need a Google email. Okay, you may need a Gmail account to do that. You might be asked to sign into your Gmail account. Okay, so I have already signed in, so I can directly go to my Colab account. Okay, so I'll go to this new notebook. Okay, these are my old ones. You may not have the old ones. Okay, you will have the welcome to Colab. You can check it out later. Now let's go to a new Colab. Okay, so here it will create the notebook. Okay, so this notebook you can have these code cells. Okay, so if you have a code cells like 2 plus 7 here, if you run it here, it will take a little bit of time because it's doing online. Let's wait. Okay. So you get this green mark where if your code is correctly executed. Okay, then result is shown below. So you don't have to use a print statement here. So it's like the interactive mode. You can see the 9. Okay, the result. Also this is in black color because I am using the dark mode. You can get that dark mode by, I think it's tools. Okay, let's say settings. Here I selected dark mode. Okay, otherwise it will have the light mode like you get in the first, like you get it when you go into it that one, but I have selected this dark mode. Okay, also I think I have selected the kitty mode. Okay, here that's why you can see these kittens running around. Okay, so let me cancel this one. So let's go back here. Okay, so you can have these code cells. If I want a new code cell, I can get another one. Okay, so if you create a variable in the code cell above, your code cell below also have access to that variable. Okay, so like this you can create a new code cell by clicking the code cell, and also the different in this notebook you can create these text cells. Okay, in a text cells you can type bold fonts, you can insert a picture. Okay, you can enter numbers like, and you can format it with numbers or bullets. Okay, so if I want a bold letter, bold one here, for example, I can here type something. Okay, let's leave it like that and bold text. If I enter, you can see it's bold. Okay, this is dark mode, so it's look like this. The important thing about this notebook, here you can write your note about the code. Okay, you can write some notes about your code, about each code cell, explaining your code cell. So that is why this is called a notebook. Okay, so that is very helpful. You can have nice comments about your code below in the top code cell. So one important thing is to support the LaTeX. Okay, so you may not know LaTeX still, you might learn LaTeX in later classes. That is the typesetting software normally we use when we want to type mathematical documents. Okay, if you are doing publications, most of the case you have to submit it in LaTeX format. LaTeX is the typesetting software I use to create your calculus note also. So you will learn it in a later class. You don't have to worry about it here, but I will show you some LaTeX code here. Okay, so if you typing mathematical things, you need to type in between $2 signs. Okay, so for example, if I want to type a fraction, I can use dfrac is better for fractions. Okay, I can do if I want a square, I can say plus, let's say C. Okay, then I can close my dollar sign by adding another dollar sign. Now I enter shift enter. Okay, so you can see it's nicely in math format. Okay, so you can use these LaTeX things to here write mathematical symbols and formulas explaining your code below. Okay, so then you can have it as a notebook. So if you are doing a thesis or something using Python code to get your physics or math problem solved, you can use this one. Okay, here you can write your problem and your equations using LaTeX. Then below you can write the code to solve the problem. Okay, so when you want to do these mathematical things symbolically, doing analytical calculations of limits and differentiations, you can use this SymPy. Okay, library. So this SymPy library is a library like math library. We already use math and random library. It's another library, so you can just import it. Okay, import. Here I can give a name. Okay, I think of this SymPy. Okay, sorry. SMS. Okay, we have done that. We imported math library as random as RM. Okay, so here when you use as SMS instead of SymPy everywhere, I can use SMS. Okay, so we execute this one. So this green sign means it's okay. Okay, so I will add another code sign. Now I can create a symbol. Okay, so one thing to create symbol. So normally we will have to say SymPy here, but instead of that I can say SMS now. Okay, SMS dot so I can say here let's Okay, so this will create a symbol called, okay, sorry, okay, symbol, I think it's symbol, let me try. Okay, okay, give me a minute to check that. I just missed the M here, so okay, just put symbol and feed into it. Okay, let's see. Okay, now it created a, okay, sorry, I missed the M, and then we should have S here. Okay, so it's okay, now it's created the symbol called X. Okay, I can go to this one and work with X. For example, if I start like this will create the mathematical expression x squared. Okay, so if I want to create two variables, I can create here y comma y. Okay, here I can say okay, so here I can create a function out of this if I want. Okay, now it will not show function. Let's go for a new function. If I put f, it will show x squared plus y squared. Okay, so if I want here, I can do substitution. I can go sub x and 4. Okay, so this will substitute. Okay, sorry, I think it should be subs. Okay, subs. It will substitute 4 for x. See, x squared is 16. You can get y squared 16. Okay, so you can create different functions using this SymPy. Using mathematical expressions like this, you can create mathematical expressions. Also, I can create the exponential function if I want. Cex. Okay, so it gives the mathematical form. Okay, also if I want, I can get the sine function here. Okay, here I can substitute it for give it for a function, and I can evaluate here using it. Okay, let's see. Okay, signed on. Okay, so you can evaluate. For example, I can do x.5. Okay, so if I do this one, it will evaluate and give the result 0. Okay, and if I use pi over 2, it will give 1. Okay, and I can do pi over 4 and see, it will give square root 2 over 2. Okay, so it will give it in this form. Okay, so you can use this stream to create mathematical expressions and functions. and use this substitution method to substitute values into that one, okay, function. So next we will talk about a calculus concept, limits, okay, how to do limits using SymPy, okay. So I will erase this, let's erase this one too, okay. Undo, okay, undo. I need this x and y variables, okay. Let me execute this. Now let's say, okay, before a code cell I will get another text cell. Let's say I want to evaluate this limit, okay. This is the LaTeX code for limits, okay. I think it's the LaTeX code. Let's see. Okay, so this is the LaTeX code. So display this limit nicely, okay. So you don't have to worry about the LaTeX code, okay. You will not be tested about this one in exams or anything. I'm just showing it. It's something useful for learn. If you are interested in learning LaTeX, check with me, okay. So that is very useful to learn if you as you go into higher classes, okay. If you are doing a math special, they will have I think they have a LaTeX class or a LaTeX workshop for you guys, okay. So here, okay, this look like this. You can actually improve this one putting a display style here, okay. Okay, this side shows how it looks like, okay. Display this input type, that okay. So it shows this side how it will look like, okay. This tool thing is not working. Let me think I need this here. Let me see. Yeah, now it's fine, okay. So this is the LaTeX code, and now we are going to evaluate this limit using SymPy, okay. So this is how you get it from LaTeX. You don't have to worry about that part, okay. So here I want to calculate this limit, right limit, no, 2 going to positive side, so that is right limit. So I want to calculate right limit using SymPy, okay. So this limit, okay. So the first thing to do here is to create this symbolic expression, okay. So I will do x star star 2 minus 5 x plus 6 no, okay, divided by x squared minus 4. Okay, so this will x here. Again I accidentally put the LaTeX one. Okay, I will put star 2. So this gives me this expression. No, now to do limit of this one, I will do SMS dot limit. Okay, here I will do x 0 and here I will do dir equal plus. Okay, direction equals plus. Okay, this one now. So you can see answer is -3/2. Okay, so for the right limit we got 3/2. So we'll see what is the answer for the left limit. Okay, -3/2. So for the left limit also, okay, this one will send limit not to 0, actually limit to 2. No, it's better to send it to 2. Okay, because that is the one we calculate. Okay, so if we do that one, plus limit, I will get -1/4. Okay, so the right limit is -1/4. To then I can calculate the left limit. This limit is also -1/4. So by this you can know the two-sided limit is also -1/4. Okay, so if you are using SymPy to calculate the limit, I advise you to calculate left limit and right limit. If they are equal, take the two-sided limit to be the same value. Okay, if you calculate this without the direction, you may think it will give the two-sided limit, but actually this is giving the right limit. Okay, limit from the positive side. So if you do it without the direction, its default is do the right limit from the positive side. If the limit exists, both sides are equal, it doesn't matter, but if the limits are different, you might get the wrong idea. Okay, so remember that if you are using SymPy, remember the command, you use this limit, then you have the whatever your expression here, comma x, comma the limit value, and then the direction. Okay, dir will do here, then comma, then you have the direction. Okay, get the left limit and the right limit, and if they are equal, take the two-sided limit. Okay, reason I am telling it, if you just use without the direction, it's giving the right limit by default. So if the limit is two values, you will get the wrong conclusion. Okay, so for example, let's look at another limit. Okay, so here I will change this. Okay, let's look at this one. Okay, we will change the limit to 0 of the expression. okay, or 2E. Okay. Let's look at this one. Okay, so here again I need to first get this expression, no? So for that one I will get 2 star ext 1 over x, this guy divided by SMS 1 over x. Okay, plus 1. Okay, let's see how this look like. Okay, this is the required expression, no? 2x 1 over x. Okay, now we can calculate the limit of this one. So I will do SMS dot limit x 0 dir plus. Okay, let's look at this one. We will get 2. Okay, so the limit from the positive side for this guy is 2. That means right side limit is 2. So let's look at the left limit. Okay, left limit is what? 0. Okay, so the left limit for this guy is 0, right limit for this guy is 2. So the two-sided limit for this guy is undefined. Okay, two-sided limit for this guy is undefined. Okay, but what happens if I calculate it without the direction? It gives 2, which is the right limit, no? So it's giving the default right limit. So if you try to calculate the limit using directly this one, in the case you have a left limit or right limit different, you will get into a wrong conclusion. Okay, so make sure you do the right limit separately and left limit separately and get the result from that. Okay, if the two are equal, you can conclude that the two-sided limit is also defined. Okay, so remember that when you are calculating limits using SymPy. Okay, so you can calculate more complicated limits using that and save your time. Okay, if you are doing physics and you want to calculate a limit, physics homework or something, you want to calculate limit, you can use the SymPy. Okay, and you can include the SymPy code and these notes in your answer. Okay, so that's nice to know SymPy and this Google Colab. Okay, so here you can download this one, okay, this notebook, okay, you can print it, okay, so you can download or print it, okay, and include it with your homework, okay. So here you can type your text problem, and down you can show the code you use to calculate the answers, okay. So I will stop the discussion about this one here, SymPy. In the next video I will show you how to differentiate using SymPy, okay. Hope this is clear, how to evaluate the limits and to get these symbolic functions, okay. Next one I will show you how to differentiate, and then another video I will show you how to integrate using SymPy. Hope this limit one is clear, okay. I will stop here.